Welcome to our deep dive into projectile motion. Have you ever wondered how a basketball arcs gracefully into the hoop or how a soccer ball curves through the air? These everyday phenomena are all examples of projectile motion. In this video, we'll explore what projectile motion is, why it matters, and how it shapes the world around us. By the end, you'll understand the forces at play and the equations that predict the path of any object thrown, kicked, or launched. Let's start our journey by defining what makes motion projectile and why it's so fascinating to scientists and athletes alike. Projectile is any object that is thrown, dropped, or otherwise propelled and then continues in motion by its own inertia, affected only by gravity and air resistance. Think of a baseball flying through the air or a cannonball launched from a cannon. Once these objects are in motion, they follow a specific path determined by the forces acting on them. Understanding what qualifies as a projectile helps us analyze and predict their motion. In the next scene, we'll look at the forces that influence this unique type of movement. When an object becomes a projectile, two main forces act on it: gravity and air resistance. Gravity pulls the object downward, giving the path its characteristic curve. Air resistance, on the other hand, slows the object down, especially at higher speeds or with larger surface areas. In most basic physics problems, we ignore air resistance to simplify calculations, but in real life it can have a significant effect. Next, let's break down the motion of a projectile into its horizontal and vertical components. Projectile motion can be separated into two independent parts: horizontal and vertical motion. Horizontally, the object moves at a constant speed, assuming no air resistance. Vertically, the object accelerates downward due to gravity. These two motions combine to create the familiar curved path of a projectile. By analyzing each component separately, we can predict where and when the projectile will land. Let's see how these components work together in the next scene. One of the most fascinating aspects of projectile motion is its parabolic path. When you throw a ball, it doesn't travel in a straight line but follows a smooth curved arc. This shape is called a parabola, and it's a direct result of the constant horizontal speed and the accelerating vertical motion caused by gravity. Understanding this parabolic trajectory is key to predicting where a projectile will land. Next, we'll look at the equations that describe this path. To describe projectile motion mathematically, we use a set of equations that relate position, velocity, acceleration, and time. For horizontal motion, the distance traveled equals the initial velocity times time. For vertical motion, we use equations that account for the acceleration due to gravity. These formulas allow us to calculate how far and how high a projectile will go, as well as how long it will stay in the air. Next, let's apply these equations to a real-world example. Imagine you throw a ball horizontally from a certain height. Using the equations of motion, you can predict how far the ball will travel before it hits the ground. By knowing the initial speed and the height from which the ball is thrown, you can calculate the time it takes to fall in the horizontal distance covered. This simple example demonstrates how physics helps us understand and predict the outcome of everyday actions. Next, we'll explore how the angle of launch affects projectile motion. Angle at which a projectile is launched plays a crucial role in determining its range and height. Launching at a low angle results in a longer, flatter path, while a higher angle produces a steeper, shorter arc. The optimal angle for maximum range, assuming no air resistance, is 45 degrees. Understanding how launch angle influences motion is essential for athletes, engineers, and anyone interested in predicting projectile paths. Next, let's see how initial velocity impacts the motion. Initial velocity, or the speed at which a projectile is launched, directly affects how far and how high it will travel. A greater initial velocity means the projectile will cover more distance and reach a higher peak. Both the magnitude and direction of this velocity are important. By adjusting the initial speed, you can control the outcome of the projectile's path. Next, we'll discuss the effect of gravity on projectile motion. Gravity is the force that pulls projectiles downward, shaping their curved paths. On Earth, gravity accelerates objects at 9.8 meters per second squared. This constant acceleration means that regardless of the projectile's mass, all objects fall at the same rate when air resistance is ignored. Gravity determines how quickly a projectile descends and when it will hit the ground. Next, let's look at the effect of air resistance in real-world scenarios. Real-world situations, air resistance can't be ignored. It acts opposite to the direction of motion, slowing the projectile down and altering its path. The effect of air resistance depends on the shape, size, and speed of the object. For example, a feather falls much slower than a stone because of greater air resistance. Understanding air resistance is crucial for accurate predictions in sports, engineering, and even space travel. Next, we'll see how to calculate the range of a projectile. Range of a projectile is the horizontal distance it travels before hitting the ground. To calculate this, you need to know the initial velocity, launch angle, and height. Using the equations of motion, you can determine the time the projectile spends in the air and multiply it by the horizontal speed. This calculation is essential for predicting where a projectile will land. Next, we'll discuss the concept of maximum height. Maximum height is the highest point a projectile reaches during its flight. It occurs when the vertical component of velocity becomes zero, right before the object starts descending. Calculating maximum height helps us understand how high a projectile will go, which is important in sports like basketball or volleyball. The higher the initial vertical velocity, the greater the maximum height. Next, let's look at the time of flight. Time of flight is the total time a projectile spends in the air from launch to landing. It depends on the initial velocity, launch angle, and height. By calculating the time of flight, we can predict when the projectile will hit the ground. This is especially useful in sports and engineering applications. Next, we'll examine the symmetry of projectile motion. Projectile motion is symmetrical when launched and landed at the same height. The path up mirrors the path down, and the time to reach the highest point is equal to the time to descend. This symmetry makes calculations easier and helps us understand the motion's predictability. Next, let's see how projectile motion applies to real-life activities. Projectile motion is everywhere in sports. Whether it's a basketball shot, a soccer kick, or a javelin throw, understanding the physics behind these actions can improve performance. Athletes and coaches use knowledge of projectile motion to optimize angles, speeds, and techniques for better results. Next, we'll explore projectile motion in engineering and technology. Engineers use projectile motion principles to design everything from bridges to roller coasters. Understanding how objects move through the air helps in planning safe and efficient structures. For example, launching satellites or designing water fountains relies on accurate predictions of projectile paths. Next, let's look at projectile motion in nature. Nature is full of examples of projectile motion. Animals like dolphins and frogs leap in arcs to catch prey or escape predators. Seeds are dispersed by plants in parabolic paths to maximize their spread. Observing these natural projectiles helps scientists understand evolution and adaptation. Next, we'll discuss common misconceptions about projectile motion. Many people believe that heavier objects fall faster than lighter ones, but in the absence of air resistance, all objects fall at the same rate. Another misconception is that the horizontal and vertical motions affect each other, but they are independent. Clearing up these misunderstandings is important for a solid grasp of physics. Next, let's see how to experiment with projectile motion at home. You can explore projectile motion with simple experiments at home. Try tossing different objects and observing their paths. Use a stopwatch to measure time of flight or a tape measure to check range. These hands-on activities make learning physics fun and memorable. Next, we'll discuss how technology helps us study projectile motion. Modern technology like motion sensors and high-speed cameras allows us to analyze projectile motion in detail. These tools capture precise data on speed, angle, and trajectory, making it easier to understand and teach the concepts. Technology also helps in simulations and virtual labs, providing safe and repeatable experiments. Next, let's look at the history of projectile motion study. Study of projectile motion dates back to ancient times. Early scientists like Galileo and Newton made groundbreaking discoveries about how objects move. Galileo's experiments showed that projectiles follow a curved path, while Newton's laws provided the mathematical framework. Understanding this history helps us appreciate the progress in physics. Next, we'll discuss the role of mathematics in projectile motion. Mathematics is the language of physics, and it plays a crucial role in describing projectile motion. Equations allow us to predict outcomes, optimize designs, and solve real-world problems. By mastering the math behind projectile motion, you gain powerful tools for science and engineering. Next, let's look at some advanced applications. Projectile motion isn't just for sports and simple experiments. It's used in designing rockets, predicting asteroid paths, and even in video game physics engines. Engineers and scientists rely on these principles for safety and accuracy in complex projects. Next, we'll discuss how to solve projectile motion problems step by step. Solve projectile motion problems. Start by breaking the motion into horizontal and vertical components. Identify known values such as initial velocity and angle and use the appropriate equations. Work through the calculations systematically to find range, height, or time of flight. Practice makes perfect, so try solving different scenarios. Next, let's look at common mistakes to avoid. Frequent mistake is mixing up horizontal and vertical motions or using the wrong equations. Another is forgetting to convert angles to radians when required. Double-check your work and make sure you understand the problem before solving. Avoiding these errors leads to more accurate results. Next, we'll discuss the importance of units in calculations. Using the correct units is vital in physics calculations. Mixing meters with centimeters or seconds with minutes can lead to incorrect answers. Always check your units and convert them as needed before plugging values into equations. This attention to detail ensures your results are reliable. Next, let's look at how graphs help visualize projectile motion. Graphs are powerful tools for visualizing projectile motion. By plotting position versus time or height versus distance, you can see the parabolic path and analyze key points like maximum height and range. Graphs make it easier to spot trends and understand the relationships between variables. Next, we'll discuss the role of vectors in projectile motion. Projectile motion involves vectors which have both magnitude and direction. The initial velocity is a vector, and it can be broken down into horizontal and vertical components. Understanding vectors helps you analyze and solve problems more effectively. Next, let's look at how to use trigonometry in projectile motion. Trigonometry is essential for breaking down the initial velocity into horizontal and vertical components. By using sine and cosine functions, you can calculate these components based on the launch angle. This mathematical approach simplifies problem solving and leads to more accurate predictions. Next, we'll discuss the effect of different surfaces on projectile motion. The surface from which a projectile is launched can affect its motion. For example, launching from a smooth, hard surface may result in a longer range compared to a rough or soft surface. Friction and bounce also play roles in how the projectile behaves after landing. Next, let's look at the influence of wind and weather. Wind and weather conditions can significantly alter projectile motion. A strong headwind can reduce range while a tailwind can increase it. Rain or humidity may also affect air resistance. Understanding these factors is important for accurate predictions in outdoor activities. Next, we'll discuss the concept of relative motion. Relative motion refers to how the motion of a projectile appears from different reference points. For example, a ball thrown on a moving train has a different path relative to the train than to the ground. Understanding relative motion is crucial in physics and helps explain complex scenarios. Next, let's look at multi-stage projectile motion. Some projectiles experience multiple stages, such as a rocket that burns fuel and then coasts. Each stage has its own set of forces and motion characteristics. Analyzing multi-stage motion requires breaking down each phase and applying the appropriate equations. Next, we'll discuss the role of energy in projectile motion. Energy plays a key role in projectile motion. The initial kinetic energy determines how far and how high the projectile will travel. As the object rises, kinetic energy is converted to potential energy, and as it falls, potential energy becomes kinetic again. Understanding energy transformations helps explain the motion's behavior. Next, let's look at conservation of momentum. Momentum is conserved in projectile motion, especially in collisions or explosions. For example, when a firework explodes, the pieces move in different directions, but the total momentum remains constant. This principle is fundamental in physics and helps solve complex problems. Next, we'll discuss projectile motion in space. In space, projectile motion behaves differently because there's no air resistance and gravity can vary. Objects continue moving in a straight line unless acted upon by another force. This principle is crucial for space missions and satellite launches. Next, let's look at how projectile motion is used in entertainment and media. Projectile motion is often depicted in movies, video games, and animations. Realistic physics makes scenes more believable and engaging. Game developers and animators use the principles of projectile motion to create lifelike actions and effects. Next, we'll discuss how to teach projectile motion effectively. Effective teaching of projectile motion combines theory with hands-on activities. Demonstrations, experiments, and visual aids help students grasp the concepts. Using real-life examples makes learning more relatable and engaging. Next, we'll look at careers that use projectile motion. Many careers rely on an understanding of projectile motion, from athletes and coaches to engineers, scientists, and even animators. Mastering these concepts opens doors to exciting opportunities in sports, technology, and research. Next, we'll discuss the future of projectile motion studies. As technology advances, our understanding of projectile motion continues to grow. New materials, faster computers, and better measurement tools allow for more precise predictions and innovative applications. The study of projectile motion will remain important in science and engineering for years to come. Next, let's review the key points covered in this video. We've covered the basics of projectile motion, including definitions, forces, equations, and real-world applications. We explored how angle, velocity, gravity, and air resistance affect motion, and discussed advanced topics like energy, momentum, and space travel. Understanding these principles helps us make sense of the world and solve practical problems. Next, let's see how you can continue learning. To deepen your understanding of projectile motion, try solving more problems, conducting experiments, or exploring online simulations. Many resources are available to help you master the concepts and apply them in new ways. Stay curious and keep exploring the fascinating world of physics. Next, we'll provide some recommended resources. There are many books, websites, and videos dedicated to projectile motion. Look for interactive tutorials, physics textbooks, and educational channels that offer clear explanations and engaging demonstrations. These resources can help you build a strong foundation and inspire further study. Next, let's wrap up our journey through projectile motion. Projectile motion is a fundamental concept in physics that explains the paths of objects we see every day. From sports to engineering, understanding these principles helps us predict, design, and innovate. We hope this video has given you a solid grasp of projectile motion and inspired you to keep learning. Thank you for joining us on this journey through the fascinating world of physics.